Acid-base titration, we're looking specifically at a strong acid and a strong base. A titration is where there's a concentration of an unknown acid or an unknown base that we don't know about, but we can determine it by actually adding a known volume of a specific acid or base concentration. What is a neutralization? Neutralization is when you have an acid and a base and they create salt and water. Also, in order for a full neutralization to occur, they need to fully react literally all of their moles. Okay, so all of the moles of the acid and all of the moles of the base. I'll put here as an example on the side that the amount of moles of the hydrogen, okay, or the hydronium must equal to the amount of moles of the hydroxide. Once that they equal, you have a full neutralization. Let's have a look at this graph down here. Let's have a pH scale, okay, on the side of here of the y-axis, and as you can see, it is 1, which means that this is going to be quite acidic. Okay, let's use hydrochloric acid as a very common example. Again, very acidic, strong acid. And then we're going to be adding it, as you can see by here, right? We add a known volume of acid or base. In this case, we got to be doing our base because we need to hit the equivalence point to do titration. So we have a volume of our NaOH, our strong base. We add it in. We go up the scale all the way up to like 75 over here. But as you can see, as it's going up, okay, and then the slope increases. Once we hit 50, you see how it's now a vertical line, okay? This vertical line means we've hit the equivalence point. At the equivalence point, this is the point at which the amount of moles added is actually equal to the amount of moles present, okay? Also known as the point at which the acid and base completely react. This is when we hit complete neutralization, okay? Because as you can see here, the pH of 7, which is neutral, this is the level of the scale where we've seen this equivalence point of it being completely vertical, okay? Past this point, now we're becoming a little bit more basic, okay? So that's what has to do with more the end point, okay? It's when the indicator changes color, meaning that the titration has stopped, okay? And as you can see, we have our volumes on both sides, we have our concentrations on both sides, which means we could easily find the amount of moles, okay? So in this case, we have 4.7 times 10 to the negative 4. You could easily calculate that with C equals to N over V. We get that in the amount of moles for the left side. We can even do the same thing on this side, okay? We end up getting, on this side, 2.9, okay? So 2.9 times 10 to the negative 4 moles, okay? So what are we going to be doing now if we have pretty much all of our variables? Well, you have to actually subtract this with this, okay? So you end up getting a value of 1.78. 1.78 times 10 to the negative 4 moles. Why do we do this? Because we have to find the difference between the two, because again, they need to fully react for titration. In this case, they're not going to fully react. Okay, we're going to have some leftovers. It's going to be a little bit more acidic though, because this is going to be larger than this. So this here has to do with an acidic value. We're going to be putting this up here in the numerator. We can't forget these solutions of both liters, so we add them together. And then of course, this is going to be a concentration of a little bit more acidity because it was bigger in the beginning. So we have to put it in a pH formula, not a pOH. So this, our answer up here, is going to go down here, and then we get a value of 2.5.